Okay, here's warm up 12R. We're going to find the probability of randomly selecting a vowel or the letters quiz. So the letters of an alphabet are in a bag, and we want the probability of selecting a vowel or the letters quiz. All right, so let's see, probability vowel or QUIZ. Okay, so let's think about this. We want the favorable over the total, the favorable outcomes over the total outcomes. Okay, the total outcomes, well, you got to know how many letters there are in the alphabet. There's 26. Okay, and then let's make a little list of the favorable outcomes over here. Let's just count them up. So our vowels, A, E, I, O, U. I know some people count Y, but let's just count A, E, I, O, U as our vowels, okay? And then the letters in quiz. I've got Q. Well, hey, I already got the U here. I already have the I here. So I don't want to write them down again because there's only one of each letter in the bag, okay? So those are my favorable outcomes. 1, 2, 3, 4, 5, 6, 7. There are seven favorable outcomes out of the 26. That one's not going to reduce, okay? So, yeah, since there's some overlap between those two categories, if you just found the probability of the vowels plus the probability of the QUIZ, then you'd have to subtract out the probability that both of those things is happening at once, and both those things that would happen at once with those two letters, right? Okay. All right, next up, how many 7-digit phone numbers could be formed if the first digit cannot be 0 or 1? Okay, we got a 7-digit phone number. So I'm going to set up just some blanks here. Okay, so there's my 7-digit phone number. I just got a little dash there like it's usually set up. Okay, so I'm just going to use the fundamental counting principle here. I'm going to think how many different digits could go in each slot. So it says the first digit cannot be 0 or 1. So the total digits we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So there's 10 total digits, but 2 of them can't be used in this first slot. So that means there's 8 total things that can be used here. Okay. Now we have to put some number in this first slot. So this is the number of options, right? In this second slot, there's 10 digits to choose from, but since no digit can be repeated, let's say we had a 7 in that first slot. Well, we can't reuse the 7, so that means there's 9 choices on this slot. You can't use a 0 or 1 here and on all the rest of them. Okay? And then now I'll have used up 2 different digits, so there's only 8 total options left, and then 7, and then 6, and then 5, and then 4, because you use up one more digit as you go. Since we can't use repeats, it's going to work like that. Okay, so if I'm thinking about those as my categories, fundamental counting principle, I multiply the number of options in each category together, and I should get the total number of outcomes. So let's go ahead and try this out. 8 times 9 times 8 times 7 times 6 times 4. That gives me a rather large number. I've got 483,840 total phone numbers. Okay? All right. There are 3 nickels, 2 dimes, and 5 quarters in a purse. 3 coins are randomly selected in succession. Find the probability that it goes nickel, then dime, then quarter. Okay, with replacement. Okay, we're going to be multiplying like this. Okay? So a nickel, that's 3 out of the, let's see, there's 10 total coins, right? 3 plus 2 plus 5. So 3 out of the 10 are nickels, but then we're going to put it back in the purse. So there's always going to be 10 coins in the purse as we draw these out, okay? And then there's 2 dimes and 5 quarters. So we multiply that all together. So let's see, on top we've got 6 times 5 would be 30. Over 1,000. That's going to reduce to 3 over 100. Okay. Same kind of setup on this one, except without replacement, that means on the second draw, we're not putting that first nickel back in the bag. So we got to assume that a nickel's already been drawn out of the bag, like so, right? This means probability of pulling a dime, assuming that a nickel has been removed. And then we want the probability of pulling a quarter, assuming that a nickel and a dime have been removed, okay? So we're starting with 10 coins, 3 of them are nickels, but then on the second draw, there's only going to be 9 coins left because we've removed that nickel. And then on the third draw, since we're not putting these back, there's only going to be 8 coins left, okay? So there'll still be 2 dimes to choose from there out of the 9 coins, and then it'll still be 5 quarters, but there'll only be 8 coins left. Okay, so I multiply on top, on bottom, that's going to be 720. And then that's going to reduce to 1 over 24. Okay, if you divide by 30 on top and bottom. Okay. All right, last problem. 2 cards are selected from a standard deck of 52 cards. Find the probability that 2 black cards are selected in a row with replacement. Okay, so we want the probability of drawing a black, and then we're resetting the deck. So find the probability of pulling black again. Well, it's half the deck. It's 26 out of the 52 cards. You could put 26 out of 52, but that's just half the deck, right? So this will be 1/4 probability of pulling 2 black cards in a row. Okay, this is a little different now without replacement because on the second draw we got to assume that a black card has already been removed from the deck. Okay, so we got 1/2 the deck is black here, or you could put 26 out of 52 if you wanted. On the second draw, starts with 26 black cards, so that means there will be 25 black cards left, and there would only be 51 total cards left. Okay, so when we multiply this, we're going to get 25 over 102, and I believe that is reduced. Yeah, it is. So that's it. Okay, that is the end of the warm-up. See you next time.